Picture this. You're an offshore engineer, and you've just struck a massive, highly productive energy reserve. It's a huge win, right? Well, there's a pretty massive catch. It's located a staggering 1,000 kilometers offshore. You are out in extremely deep water, literally miles and miles away from any existing infrastructure. Now, building a subsea pipeline across that vast distance back to shore, that would cost exponentially more than the entire value of the field itself. So you're faced with this massive, seemingly impossible logistical puzzle. How exactly do you extract, process, and transport that product back to civilization when traditional methods are completely off the table?
Welcome to today's Explainer. I'm super excited to guide you through this because we're going to unpack the offshore industry's ultimate answer to that exact problem. We're zeroing in on the absolute modern workhorse of the ocean, the FPSO megaship. These things are incredible. They're essentially self-sustaining floating cities, and they have completely revolutionized deepwater energy extraction over the last 20 years. If you've ever wondered how our modern world is actually powered from its most remote oceans, you are definitely in the right place.
All right, here's our roadmap for today. Think of this agenda as our engineering blueprint. Number 1, deepwater's ultimate engineering solution. 2, anatomy of the FPSO. 3, the genius of weather vaning. 4, conquering the ocean's motion. 5, why FPSOs dominate offshore. And finally, number 6, the support ecosystem. Let's get right into it.
Section 1. Deepwater's ultimate engineering solution, moving past the pipeline. To really appreciate the genius of what an FPSO does, we first have to understand the geographical limits of getting resources out of the deep ocean.
For decades, the fixed-jacket platform was the traditional workhorse of the offshore industry. These structures are built directly into the seabed, so they're incredibly stable, giving you a fixed, unmoving base of operations right above the waves. But there's a catch. They're severely limited by water depth, and crucially, they absolutely require a permanent subsea pipeline to pump the product back to shore. When you push far offshore into extreme deep water, building that massive structure and laying all that pipeline becomes physically and financially impossible. Enter our modern workhorse, the FPSO. It operates effortlessly in deep water environments and, this is the game changer, it completely eliminates the need for a pipeline. It essentially cuts the cord, offering unmatched, self-contained flexibility.
Moving on to Section 2. Anatomy of the FPSO, the all-in-one vessel. Let's break down how these incredible megaships are actually put together.
So what exactly is it? Well, the acronym actually tells the whole story. FPSO stands for Floating, Production, Storage, and Offloading. It's a single, self-contained vessel that literally handles the whole shebang. It extracts the crude oil straight up from the subsea wells. It processes it right there on board to remove water, gas, and any impurities. And then it safely stores that stabilized crude inside its massive hull until it can be shipped out to market. It's basically the ultimate Swiss Army knife of the ocean, rolling a drilling platform, a chemical refinery, and a massive storage facility all into one single ship.
To really grasp the sheer scale of this engineering, think about a vessel like the BP Skillion FPSO. It has these massive, extensive process modules mounted on structural skids right above the main deck. Now, they elevate these modules about 3 meters on purpose to provide a crucial air gap. Why? To protect the highly sensitive processing equipment from green seas, which is just a maritime term for those giant, heavy waves that can crash directly over the deck during a massive storm. And right near the bow, there is a massive internal cylindrical structure extending vertically down through the ship and into the water. That's the internal turret system, and honestly, it's the absolute beating heart of this vessel's ability to survive out there.
Which brings us to Section 3, the genius of weather vaning, taming the environment. Because these vessels are ship-shaped, they are entirely at the mercy of a dynamic, violently moving ocean. So how on earth do they survive a massive hurricane without being ripped away from their subsea wells?
Well, the solution starts with the mooring layout. We're talking 8 to 16 massive heavy-duty chains anchoring the vessel firmly to the seabed. These connect directly to the internal mechanical workings of that turret we just talked about. But here's the absolute genius of it. The turret itself is fixed to the seabed. It does not rotate. Instead, the entire massive ship rotates around it on colossal roller bearings. This is called weather vaning. So when a storm hits, the ship automatically pivots, sometimes up to 270 degrees. So the bow points directly into the combined forces of the wind, the waves, and the ocean current. It's constantly seeking the path of least resistance. Now, as a quirky side note, some unconventional designs, like the Savon Marine concept, actually use a circular cylindrical hull. Because they're round, they present the exact same profile to the waves from any direction, so they don't even need to weather in at all. But for your traditional ship-shaped vessels, this rotating turret is everything. It allows sophisticated fluid swivels inside to keep the oil flowing up from the seabed, even while a 100,000-ton ship spins circles around it.
Let's look at Section 4, Conquering the Ocean's Motion, Transferring the Payload. Okay, so we've successfully extracted, processed, and stored the oil. But how do we safely get it off a ship that's constantly bobbing around in the open sea?
Even before we offload, just think about the processing phase. The constant rolling, pitching, and heaving of the ship makes refining incredibly difficult. Standard onshore refining equipment fully expects to sit on solid, unmoving ground, right? So engineers actually have to custom design these topside modules just to handle the liquid sloshing around inside the tanks. But to get the oil off safely once it's finally processed, we use what's called a tandem offloading process. It basically happens in 3 steps. Step 1, the FPSO steadily stores the processed crude in its massive hull tanks until they're totally full, which usually takes a week or 2. Step 2, a specialized shuttle tanker arrives to collect the payload, but it has to trail at a safe distance behind the FPSO. It can't just pull up alongside it like it would in a calm port. That's way too dangerous out in the open ocean. And step 3, a massive flexible floating hose is reeled out from the stern of the FPSO to connect the 2 vessels, and that's when the high-volume transfer begins.
Picture that, shuttle tanker positioned stern to stern with the FPSO. The crucial link between them is that long, flexible hose trailing through the water. By maintaining the specific tandem configuration, the shuttle tanker can safely load up the oil even when the wave conditions get really rough. Both of these massive ships are using powerful dynamic positioning thrusters and thick mooring hawsers to constantly adjust their heading. They literally have to work in perfect synchronization to maintain that safe distance, so they never collide in the rolling ocean swells. It is literally a highly choreographed mechanical dance right in the middle of the ocean.
Section 5, Why FPSOs Dominate Offshore, the Economic Drivers. We've seen all this incredible engineering, but why has the energy industry so universally adopted this technology over the last 20 years? It really boils down to a few extremely punchy logistical and financial benefits. First, as we covered at the very beginning, it completely eliminates the need for a 1,000-kilometer subsea pipeline. If you're that far offshore, the pipeline alone could bankrupt a project before you even drill a single hole. Second, they are highly redeployable. If a deepwater oil field only has a 10 to 15-year production lifespan, you simply cannot justify building permanent fixed infrastructure. With an FPSO, when the well runs dry, you just disconnect the ship from its moorings, tow it to a shipyard for a quick refit, and boom, you deploy it to a brand new field. And third, a lot of FPSOs aren't even built from scratch. Operators frequently buy existing supertankers, strip out the old cargo pumps, slap on the topside modules, and convert them in a dry dock. That dramatically saves time and cuts massive capital construction costs compared to building a custom hull from the ground up.
And finally, Section 6, the support ecosystem, the lifeline fleet. Let's zoom out for just a second. An FPSO doesn't just float out there alone in a vacuum. It's actually the beating heart of a much larger, highly coordinated maritime ecosystem.
To keep a floating city alive, you need a specialized fleet constantly buzzing around it. First up is the Platform Supply Vessel, or PSV. Think of this as the offshore freight truck. It has a massive open cargo deck and uses dynamic positioning to safely drop off fresh pipes, chemicals, food, and supplies. Second, the Anchor Handling Tug Supply Vessel, or AHTS. This is the heavy hitter of the ocean. It uses massive towing power to literally drag 15-ton anchors across the seabed to securely moor the FPSO in place. And lastly, the Emergency Response and Rescue Vessel, or ERRV. By maritime law, there is always a standby rescue ship nearby. They're equipped with fast rescue crafts and are constantly monitoring the FPSO just in case of a man overboard or any critical emergency.
Operating this diverse offshore support ecosystem is constant, extremely dangerous work. You've got highly skilled crane operators up on the FPSO relentlessly lifting heavy cargo baskets off the open decks of these supply ships. And those supply ships, they're violently bobbing up and down in rough swells right below them. The dynamic positioning computers on those ships are working in absolute overdrive, firing side thrusters to hold the vessels within just a few meters of the massive platforms, even in gale force winds. It is a tireless 24/7 operation requiring immense skill and coordination just to ensure the FPSO remains fully operational and, above all, safe.
And that brings us to the end of our explainer today. We've journeyed all the way from an impossible deep-water logistical nightmare to understanding the ingenious, rotating megaships that quietly solve it every single day. We've seen how they weather vane through violent storms, transfer massive payloads on the open waves, and drastically reshape the economics of global energy. So next time you look out at the ocean, will you picture the massive, invisible floating cities engineered to power our modern world? Keep learning, keep asking questions, and I'll catch you in the next explainer.